All right, hey everyone. So our optimization unit continues with optimizing area. Okay, so they do now refer to this optimization handout that I posted on Google Classroom, but I have the questions here on the slide. So please get started on that, and then we will discuss in 2 minutes. Okay, so let me pause you here. Can I get a volunteer to read this question here, number 5?
Find the dimensions of the rectangle having perimeter 24 centimeters and area as large as possible.
All right, thank you for that. So this is a question that we've seen in previous lessons, right? So you might already know the answer. Um, and at this point, feel free to type in the chat what you got for questions 5 and 6. But essentially, what we're going to do is, we're going to set up the perimeter equation, right? 2L plus 2W, where L and W are length and width, and then simplify and then express the area of the rectangle in terms of one of the variables. Okay. Okay. So for that, let me scroll up to the solution. And you might also remember that the area is going to be maximized when the rectangle is a square. Okay. So here I have, so instead of L and W, I have X and Y. I have 2x plus 2y equals 24, and then I divide both sides by 2. So divide each term by 2, you get x plus y equals 12, and then I'm going to rewrite everything, or isolate y rather, so y equals 12 minus x. So therefore the area of the rectangle is going to be x times y, which is going to be x times 12 minus x. So at this point you can use a graphing calculator to find the maximum, or you can also use the negative b over 2a formula here. If you use a graph calculator, you're going to find that it's going to be 6 centimeters by 6 centimeters. If you use the negative b over 2a formula, this is how you do so. So you do negative 12 divided by 2 times negative 1. So that'll be 6. And then, so y equals 12 minus x, which is also 6. Okay, but either way, it's going to be 6 centimeters by 6 centimeters for question 5. Okay. Question number 6 is essentially the same thing, except this time the perimeter is 80 centimeters and they're asking for the area now. Okay, so question 5, they're asking for the dimensions, so the length and the width of the rectangle. For question 6, they're asking for the maximum possible area. So that would be the y coordinate for your area function. Okay, so you start off with the same thing, 2x plus 2y equals 80, and then divide everything by 2, you get x plus y equals 40, and then isolate y, you get y equals 40 minus x. So therefore the area of the rectangle is going to be x times 40 minus x. At this point you can use a graph calculator or use negative b over 2a. All right, you're going to find that's 400 centimeters squared. For negative b over 2a, it's going to be negative 40 divided by 2 times negative 1, which is 20. Okay, and then you evaluate the function at 20. So a of 20 is 40 times 20 minus 20 squared, right? And that'll be 800 minus 400, which gives us 400 square centimeters. Okay, and yeah, that does match up with the pattern that we've seen, right? So the greatest possible area of a rectangle is when the rectangle is a square. So when the length and the width are equivalent in value. Okay, so yeah, for number 6, it was like 20 by 20 centimeters. Okay, so I'll give you a sec to copy that down. And afterwards, we'll just work on a few questions on that optimization handout. Again, it's posted on Google Classroom, but I'll display the questions here as well. Okay. Is anyone still copying these solutions? You can type in the chat or speak up. Okay, if not, then I'll move on to the worksheet. So here are the questions. We're going to work on 3 questions today. So these 3 questions are actually like, normally we have 40 minutes in class, but you probably won't be able to finish all 3. But that's okay, right? We only have we have about 17 minutes left. So we'll see if you can solve questions, the first 2, and then the last question I'm actually going to go over because there's going to be a homework question that's similar to question 29. Okay, but also 10 and 13, but 29 is probably like the most like you probably haven't seen anything like that before, so I didn't want to show you how to go about that question. Okay, but yeah, with that being said, let's reconvene at, let's say 140, yeah, let's say 140. See if we can solve questions 10 and 13 within the next 6 minutes. All right, so let me pause you here. So let's go over some of the questions. Let me start off with question 10, and then I'll go to 29. So for question 10, can I get a volunteer to read this question here, please?
Suppose you have 300 yards of fencing with which to enclose a rectangular garden, as shown in the figure. Find the dimensions that will maximize the area, and what is the maximum area?
All right, thank you for that. So for these area questions, the only thing that they could really change is like the fencing here, right? So for example, like question 10 and 13, there's going to be like 3 x variables. And then for question 13, you'll see that there's going to be like, it's going to be 2x plus y. Anyways, so as you can see from this diagram, right, there is like a middle slab, there's like a middle fence, right, right, that provides x, right, so that's going to be 3x here. So that's going to be part of the perimeter, right, because that's part of your fencing material, right, and then for the length, right, that's going to be y, but that's normal, it's 2y, right, so it's 3 of these x slabs, and then 2 y slabs for the fence. Okay, so it's going to be 3x plus 2y, and we have 300 yards in total of fencing. And then at this point, we're going to isolate one of the variables, so I decided to isolate y. So you can do 300 minus 3x, divide that by 2, and that's equal to y, right? But the area itself is x times y, so that'll be x times this expression here, 300 minus 3x divided by 2. And then at this point, you have to use your calculator. Technically, you also use negative b over 2a, right? Because this is a quadratic. But let me actually show that then. So it's x times, let me write that out. So negative 1.5 x squared, right? That came from negative 3x over 2 times x. And then we have 300 divided by 2 times x. So that's plus 150x. Well, actually, maybe it might be easier. Sorry for the formatting. Yeah, I'll just type this into Desmos. So x times 300 minus 3x divided by 2. Okay. All right. Well, does anyone still need to copy this? Otherwise, I'll proceed to show you the Desmos graph. Okay. All right. If not, then I'll go to Desmos. Okay. So this is the function we're going to graph: x times 300 minus 3x divided by 2. Don't mind this one. This is for the next question that I'm going to go over. So here we have this. All right, got to change the formatting a bit. Okay, we might have to zoom out. Yeah, so as you can see, like the maximum is, I think it was like 3,750, right there. Okay, yeah, but that's what you'd graph on Desmos or using your TID4 or other calculator, right? But you're going to see that the maximum area is 3,750 yards, square yards, and then the independent variable is going to be 50 yards. So x is equal to 50. Okay, but yeah, that's what you would do if you were to solve this graphically. And let me go back to the Word doc. Okay, but the question is asking for the maximum area, so that'll be 3,750 yards, square yards, right? And then, they also ask for dimensions, so we're gonna write that in. So as you saw from the graph, right, the x variable, the independent variable, is 50 yards, and then to solve for y, you will plug them into here. So that would be 300 minus 150, right? 3 times 50, 150. And then that's 150 divided by 2, which is 75 yards. Okay. So that'll be your answer for question 10. Okay. Does anyone still need this solution here? All right, now I'll move on to, I'm going to jump to question 29 because again, there's going to be a question on that, similar to this on the homework, and it's kind of, yeah, it's like really new in terms of like what we have to do. Okay. All right, so a wire 20 centimeters long is cut into 2 pieces. This is my diagram here. One is bent to form a circle and the other is bent to form a square. Okay, so that's the first thing that's new, right? So here we have this wire. It's cut into 2 pieces. This first piece is, I'm going to label it X. So this is bent to form a circle. And then the other part of the wire is bent to form a square. That'll become this, right? And then the question asks, where should the cut be made so that the sum of the areas of the circle and square is minimized? So, okay, so we have to minimize the sum of the areas of the circle and square. Okay, so we're going to add pi r squared plus side squared for the areas, right, and minimize that. But we need to find where x is, right? So where's the cut made? Now, the reason this problem is kind of difficult is because there's like a lot of different equations going on here. So the first equation is x becomes the circumference of the circle, right? Because the wire becomes a circle, the outside of the circle. So that'll provide the circumference, right? So x equals 2 pi r, or pi times diameter. Okay, so that's the first equation, right? So x equals the circumference of the circle, right? The next part is the other wire, right? So we have y equals 4 times s, right? Where s is like one side of the square, right? So y, this part of the wire, is bent to a square. That'll be, the perimeter of a square is 4 times the length of one side, right? So we have y equals 4s. And then from there, I'm going to jump to, so that's like step number 1. Here's step number 2, actually. So I'm going to minimize pi r squared plus s squared, right? So this is what I have to minimize, the sum of the areas of the circle and square. But the problem here is we have, 2 variables, r and s. right? So I need to rewrite everything in terms of one variable. Now the way I'm going to do that is I'm going to rewrite everything in terms of x. So here I have this step 3. So r equals x divided by 2 pi. So I divide both sides by 2 pi to isolate r. And then for y equals 20 minus x. That comes from this equation, right? Or this this diagram right here. So in other words, like if I have a wire that's 20 centimeters long, and the cut is made so that like x is equal to 12, then y is going to be equal to 8. Okay, 8 centimeters. So it'll be 20 minus x wherever that cut is made. So y equals 20 minus x. That's the other equation that we have to work with. And then lastly, we have y equals 4s. So s equals y over 4, right? Divide both sides by 4. And we need that because we need to write s in terms of x. Okay. So as we know, y is equal to 20 minus x, right? So you can plug that in here. So s equals 20 minus x over 4. Okay, so now we're ready to substitute this in, right? Into here, into these equations. Right, so we have pi r squared plus s squared. Okay. Now r, as we see here, is x divided by 2 pi. And then for s, we have 20 minus x over 4. So we're going to square both of these, and then this is the equation that you're going to plug into your calculator. You could also solve this using negative b over 2a, but right, the numbers, it involves 4 pi, so I would recommend using a graphic calculator. Okay, I'll show you Desmos in a sec, but I'm going to give you I'll give you time to copy this first, and then I'll go to Desmos to graph this function. Okay, is anyone still copying this? You can type in the chat or speak up. Otherwise, I'll go to Desmos and show you the function. Okay, I'm going to go to Desmos then. So here is the function. So this is the function in green, right? So we have x squared over 4 pi divided by, so x squared over 4 pi plus this expression, 400 minus 40x plus x squared divided by 16. Okay, so the minimum value is going to occur here. So that coordinate is 8.798, comma 14.002. Now 14.002, that's the area. That's the smallest possible area. And then x is equal to 8.798. So that's where the cut should be made. So that x is equal to this value. Okay, but that's how you would do it on Desmos. And actually, yeah, I would actually recommend using Desmos in this case because if you use your TID4 or other graphing calculator, then you're gonna have to like change the windows a bit. But yeah, anyways, the minimum is this value, and then therefore x is equal to 8.798, y is equal to 20 minus x, as we saw there. Right, so therefore it's going to be 20 minus that value, which is 11.202. Okay, so the cut should be made so that x is equal to this value, and then y is equal to 11.202, and this is in centimeters. So I'm going to write that in. Okay. All right. So while you finish copying that, let me close with announcements. Yeah, there's just is only that there's SGI today, 247. Drop by if you have questions. But yeah, if you're done copying this and you have no questions, you are free to go, and I will see you tomorrow. All right, take care.
Thank you.
All right, thanks. You too.